let's look at integration with the trig substitution where we have to do a little bit more work. So now here again, I don't have a direct u substitution for this problem because notice I don't have my du outside up with the dx. The du in this case would be 2x plus 2, the derivative of the x squared plus 2x. So again, I'm forced to use a u substitution, but notice that I'm forced to use a trig substitution. But notice that for the trig substitutions, there's supposed to be one in one of these three specific forms. So since I don't have that here, I have an x squared plus 2x, I'm first going to have to do a little bit of work to get it in the correct form. And that work is completing the square. So to complete the square on this expression, my steps are, number one, make sure that the coefficient of the x squared is a positive 1. If it's not, you need to factor out whatever is there from the x terms only, and then proceed with what we're doing. But in this case, I've already got a positive 1 as the coefficient of the x squared term there. So I just identify the middle term, the term in front of the x. That's my b term. In this case, it's 2. Divide by 2, we get a 1. And then I square it. So b over 2 squared is a positive 1. I add that and subtract it from the expression. But I'm grouping together the x terms with where I added it because those factor into a perfect square. They always factor into x plus whatever your b over 2 term was, quantity squared, and then leave the minus 1 on the outside. So I can rewrite this integral as the square root of quantity x plus 1 squared minus 1. Now we see that we are in the form right here to use a secant substitution. So I'm going to let my variable, now notice my variable is the item squared, so in this case my whole variable is the x plus 1. We'll make the substitution x plus 1 equals square root of what's here, which is 1, secant of theta. So now differentiate both sides. Derivative here is dx, derivative of the 1 is 0, equals derivative of secant is secant of theta, tangent of theta, d theta, and substitute in. So now we have dx, which is secant of theta, tangent of theta, d theta, divided by, that's going to be the square root of my x plus 1 is secant squared theta minus 1. Now, again, to replace the secant squared theta, what we're doing is we're using one of the forms of the Pythagorean identity. So our Pythagorean identity, if you remember, is sine squared x plus cosine squared x equals 1. So to get the right form, I need to divide through by cosine to make a secant. So sine divided by cosine is tangent squared of x. Cosine divided by cosine is a 1. 1 over cosine squared is secant squared. So if I subtract this to the other side, then I'd have secant squared of x minus 1 is equal to tangent. So we're going to replace this secant squared minus 1 with a tangent squared. So I have secant of theta tangent theta over the square root of tangent squared theta d theta. Square root of something squared, those cancel, right? And we just have tangent of theta, which cancels with that guy, and we're left with the integral of the secant of theta d theta. So now I need to figure out how to integrate secant of theta. Now, secant of theta is one of the integrals that we learned. The antiderivative of the secant of theta is the natural log of the absolute value of secant of theta plus tangent of theta plus c. So now what we're going to do is we've got to go back to x's because we were in thetas. And that's not what the original problem was. The original problem was x's. So I need to use this relation right here to go back from theta to x. Using trigonometric relations, we're going to use a triangle. So what we're going to do is we're going to say, well, secant of theta equals x plus 1 is the same thing as saying that if I'm looking at a triangle with an angle theta here, a right triangle, then for the secant, That's my hypotenuse over the adjacent side. So since this is the fraction x plus 1 over 1, the hypotenuse of my triangle would be x plus 1, and the adjacent side would be a 1. Now I can use the Pythagorean theorem to figure out what the remaining side is. That remaining side is the square root of the hypotenuse squared minus the side squared, right? Since side squared plus side squared equals hypotenuse squared. All right, well, we already worked this out, though. This is what we originally started with. Notice I can simplify that back to the original expression, which is x squared plus 2x. Just FOIL it and then subtract the 1. So now I can replace secant of theta. Secant of theta is just x plus 1 plus tangent of theta. Tangent of theta is going to be my opposite side over my adjacent side. So the opposite side is square root of x squared plus 2x over the adjacent side is a 1. So just like so. Close off my absolute values, put my plus c on there, and we are done.